Friday, April 13, 2029, an asteroid large enough to fill an entire soccer stadium will pass so close to Earth that it will dip below the altitude of our communication satellites. We have not named this asteroid Bambi. Instead, it is called Apus, after the Egyptian god of darkness and death. If Apus's trajectory remains as it is at the moment, the influence of Earth's gravity will steer it onto a path that will cause it to hit Earth directly 7 years later, in 2036, on its next orbit. In this case, Apus would hit the Pacific Ocean, between California and Hawaii, and the resulting tsunami would wipe out the entire west coast of North America, bury Hawaii, and devastate all the landmasses of the Pacific Ring. Neil deGrasse Tyson confronts us with gruesome prospects. Apus is undoubtedly one of the most dangerous asteroids of our time, and it will pass so close to Earth in 2029 that it will come closer to the surface than our satellites. The crucial question, then, is what effect this flyby will have on the asteroid. Apus may be pulled into an orbit in 2029 that puts it on a direct collision course with Earth. If it misses this keyhole, it will be deflected so far that we have nothing to fear in 2036. That sounds like a damn lucky thing. And we have to ask ourselves, can we really leave the fate of our civilization to luck? Apus is a small asteroid, at 340 meters in diameter. It is much smaller than the monster asteroid that wiped out the dinosaurs 66 million years ago. The Chicxulub asteroid, which crashed into the sea off the coast of Mexico, was an impressive 15 kilometers in diameter. Nevertheless, sizes like that of Apus are enough to cause terrible chaos and devastation on Earth. As Neil deGrasse Tyson suggests, Apus could trigger a tsunami that could destroy neighboring coastlines and simply wash away islands. When Apus made a distant and safe flyby of Earth on March 5, 2021, astronomers took this unique opportunity to once again precisely determine the asteroid's orbit around the Sun. The astronomers then gave the all-clear and ruled out an impact risk for the next 100 years. Nevertheless, some experts are exercising restraint on this issue, saying that we must wait until 2029 for Apus to approach Earth again. Only then can we make any real concessions about the future and the certain risk of impact. In plain language, this means that the danger from Apus continues to exist and must not be underestimated. We won't know for sure what will happen until 2029. Astronomers base their predictions on observations from optical telescopes and ground-based radar to determine the orbit of every known near-Earth object as accurately as possible. But asteroids are treacherous. They are barely visible, and their size makes them extremely difficult to observe. NASA astronomers monitor the sky as closely as possible and then report their assessments to NASA's Planetary Defense Coordination Office. If there is a risk of collision, the agency issues a planetary asteroid warning. However, NASA is optimistic. A spokesperson emphasized that the orbit of Apus could already be determined very well in 2021. Scientists have used this opportunity to obtain incredibly precise information about the distance and orbit of Apus. NASA considers this study to be forward-looking and completely sufficient to rule out a global impact. Since Apus may still hit Earth one day, it's imperative that we study objects like this asteroid better. Previous radar observations indicate that Apus has a two-lobed or peanut-like appearance. The nut shape is a relatively common shape in near-Earth asteroids, and the two lobes mean that the asteroid consists of two main parts connected by a more narrow waist. This shape is often formed when two smaller asteroids collide and stick together, or when a larger asteroid is split into two parts by gravitational forces or other influences, which nevertheless remain connected. The two-lobed structure provides important information about the composition, density, and internal structure of the asteroid, and this is exactly what we need to know in order to better understand the dynamics and behavior of such objects. In addition to the shape, the rotation speed of the asteroid and the axis around which it rotates determine the further trajectory and the reactions to contact with Earth's magnetic field. When Apus hits the gravitational field of our planet in 2029, the spin state will change, and the contact may even cause an asteroid quake, which will result in strong seismic tremors on Apus. The changes that the asteroid then undergoes will determine the further risk. Apus does not come alone. Have you breathed a sigh of relief and thought to yourself, thank goodness Apus won't hit us in 2029? Well, there's a catch to this joy. Apus is not alone. We know of around 25,000 near-Earth objects that could be on a collision course at any time. Apus is one of the most dangerous of these asteroids, and its big brother on this scale is Bennu. Bennu is another near-Earth asteroid with a diameter of around 490 meters, and it also regularly passes by Earth. The probability of Bennu hitting Earth is also currently estimated to be low, which is good, because the possible consequences of such an event would be devastating. Despite its currently harmless orbit, Bennu must be constantly monitored. Overall, we still know too little about asteroids, and we cannot rule out the possibility of these deadly projectiles suddenly changing their orbit. This can happen, for example, if the asteroids collide with each other. OSIRIS-REx and DART fend off from space. It's really fantastic to see what scientists around the world are coming up with to protect our Earth and our civilization from impactors from space. NASA developed the OSIRIS-REx and DART space missions to further expand our knowledge of asteroids. The OSIRIS-REx spacecraft was launched in September 2016 and visited the asteroid Bennu. Once there, the probe briefly crashed onto the surface of the asteroid, stirred up material, collected a sample, and flew back to Earth. Contact with the asteroid was made in October 2020, and in 2023, the samples landed in Texas, USA. The sample container contained a powdery black surface material, and several laboratories around the world set about analyzing the powder. The preliminary analysis results show a wealth of water and organic molecules, and a previously unknown material that requires further analysis. This knowledge of the composition can provide us with valuable information in the event of an emergency. If an asteroid is hurling towards us, we have to fend it off somehow. And regardless of whether we want to blow it up or shift it off course, knowing the exact composition and density of the asteroids would be crucial for success in this case. The OSIRIS-REx spacecraft probe remained in space and transformed into the OSIRIS-APEX mission, and the next target for sampling is the sinister Apus. Another smash hit in asteroid exploration was the DART spacecraft, which was designed solely to crash into the binary asteroid Didymos. NASA's intention was to deflect the asteroid's orbit by around 72 seconds, but the impact actually shifted Didymos's orbit by a whopping 33 minutes. In the case of an emergency, such a mission could save the planet. Japan lands on the monster from Japan. What hardly anyone knows is that Japan has also explored an asteroid in great detail. The Japan Aerospace Exploration Agency, JAXA, launched its Hayabusa 2 mission on December 3, 2014, and after a journey of almost 4 years, the probe reached the truly gigantic asteroid Ryugu in June 2018. This asteroid belongs to the class of C-type asteroids, which are known for their rich composition of organic and water-containing minerals. Because of these organic structures, asteroids and comets are still suspected of being the actual messengers of life in the cosmos. So, our research is not just about asteroid defense. These objects may also provide us with the answers as to where life on Earth originated. One of the main objectives of the Japanese mission was to map Ryugu's surface in detail. Hayabusa 2 collected 2 samples and placed 3 rovers on the surface of the asteroid, Minerva 21A, Minerva 21B, and the German lander mascot. These rovers and the lander have been exploring the asteroid since then. The long-term observation will provide us with further valuable data on the physical and chemical properties of the asteroid. Hayabusa 2 left Ryugu in November 2019 and returned safely to Earth with the collected samples in December 2020. These samples were also shared with scientists around the world, and to the great astonishment of researchers, a total of 15 amino acids were isolated from the powder. As the building blocks of proteins, amino acids are the basis of life. The impact is only a matter of impact history. If we look at the history of asteroid and comet impacts on Earth, the prospects are truly gruesome. In the course of the Earth's history, a violent impact occurs every 100 million years. The last asteroid of this size was Chicxulub. Since then, smaller asteroids and comets have repeatedly hit Earth, but that was enough to cause terrible devastation. As the Chelyabinsk event shows, in 2013, a previously undiscovered asteroid with a diameter of around 20 meters exploded over the city of Chelyabinsk in Russia. It exploded 30 kilometers above the ground but released an amount of energy equivalent to 500 kilotons of TNT. Although there was no direct impact damage, the shockwave injured 1,500 people and damaged 7,200 buildings in 6 cities in the region. Most of the injuries were caused by curiosity. People saw the bright flash and rushed to the windows. The shockwave traveled at about the slow speed of sound and shattered windows shortly after the lightning appeared, leaving people with nasty injuries. In 1908, a comet with a diameter of around 30 meters devastated the Tunguska region in Russia. This comet did not make it to the ground either, but the explosion tore open an area of an incredible 2,150 square kilometers and knocked down around 80 million trees like matchsticks. This explosion was estimated by experts to have 1,000 times the explosive force of the atomic bomb in Hiroshima. If this had occurred over a conurbation, the city would have been completely destroyed. Both asteroids were comparatively small but still caused devastating damage. Asteroids measuring several kilometers could endanger our entire civilization. The impact alone can almost destroy a continent. Tsunamis and climate changes in the aftermath can trigger famines and other global catastrophes. And the next big event is only a matter of time. Don't miss out on the upcoming top videos and subscribe now.